Right. VLC plugin, baby. So for context, I have a little TV show tracker where, maybe I was watching Stranger Things and maybe, I was watching season 4 and maybe, theoretically, maybe, allegedly, maybe, I might have had a list of files on my computer that looked like this. Probably not, though, because that would be crazy. I probably watched them on Netflix. But if I had a set of files on my computer that looked like this, um, what I would navigate to this folder full of files and I would double click on one and I'd play it, and then later I would come back to my TV tracker and it wouldn't be up to date, and I'd also forget which episode I was on because nowhere was I tracking this information of which episodes I've watched. So we wrote a VLC plugin that will go to my web server and it will try to parse out the name of a file. So he'll do something like what do we call this? Plugin.zig probably. This guy will when we open up a show, he will compare the name of the episode that we're watching with all of the names of shows that we have on our thing, and then he'll probably try to find if it's below some threshold, if if the name is close enough to some threshold, he'll probably then try to extract the episode number and try to go to this URL and post the watch status if the time that we've watched is over a certain percentage of the show in general, right? That's kind of how this thing works. And we have a proof of concept that does something, but it's very proof of concept, very unfinished. And today is about trying to figure out how to improve it. We gotta make it better. So the way this plugin works, is it registers itself in VLC. We compile this shared object, and it registers itself as an interface, right? So it has all of the information that the player UI has. And we then register for notifications for when the current file changes, and when that current file changes, we then shove some stuff into our Zig plugin that does all of the name matching, all of the actual work. And we also say every 1 second, could you check the time and tell us what it is so that we can do something if we need to. Yeah. So I guess we should just start knocking off some stuff. So one is that we kind of started from a Hello World VLC plugin, which is not really relevant anymore. So I think, first of all, I guess let's make sure that the current state is checkpointed somewhere. I guess. Probably this guy. We probably want a git ignore in here. I was today days old when I found I can write my own test runner and can print a nice formatted string for my tests. I guess you're talking about Zig's test runner? Yeah, I guess. Yeah, it's kind of fun. It's kind of fun. Zig out and Zig cache. Landy PBS, leave the prime. They need to work on documentation. I don't really know. I actually have no idea. I am not really a big doc reader. But I also don't think. Wait, hold on. What is in here? I see. What was I gonna say? I don't really feel like it's super missing. It's not that hard to find. If you run Zig test help, I think they talk about test runner in here. Right? And once you have that information, it's not super hard to tie back. But yeah, I guess I don't know. I don't know, even if you had really good docs, I don't know how you would find it. You know what I mean? But that's my problem, I think, is that I suck at finding documents. So maybe that's just how my brain gets corrupted. Okay. Git commit, whip, initial commit. Boom. Boom, boom, boom. Okay, let's just start fucking shit up. So, Zig, hello. Get the fuck out of here. Who? Get the fuck out of here. These, like, comments, get the fuck out of here. Get this the fuck out of here. This N underscore surely isn't needed, right? I don't know why this is here, but maybe we can kind of do this. And then do a little Zig build and just make sure everything is still above board. We do lose this who string. Who. Fuck who. Fuck who, fuck who, fuck who, fuck who, fuck who, fuck who. This is fine. Who here. Zig build. Wonderful. And then I guess, does everything still work? Just for the record, this isn't Stranger Things. We just say it's Stranger Things. Yeah, this seems like everything is still above board. Let's look at the compiler source to find out how to write it, because it seems to get a default built-in module. This normal Zig program. Oh, interesting. Interesting. I mean, the default test runner is just kind of sitting there in lib. But yeah, I think that's also, like, fine. I don't know. You're supposed to loop over built-in test functions, which is not there in import built-in. You've piqued my interest. You've piqued my interest. You've piqued my interest. What do they do? Built-in test functions. Yeah, I see it, which you're saying, like, isn't there. Because it's not in this built-in, so probably, like, when you jump to built-in, it's like, what the fuck, it's not there. But it's probably, like, yeah, because the built-in module is generated based off of your, like, compiler mode, right? So the fact that you have this, like, is test false, it means that, like, when you're building with tests, this is test will get set to true, and there will be other stuff in here. Yeah, I see. I could see that being a little confusing. Okay, also fuck this hello who config. Dude, I wish this didn't take so long. I wonder if we can figure out what was I gonna say? I want to know why the Zig self-hosted backend doesn't work. Like, when I comment this out, stuff starts crashing, if I remember correctly. Yeah. Which is annoying, right? So I wonder if we can, like, diagnose this. Because it might be fixable. And if it's fixable, we can get our compiler times way up, right? So it feels like, when we use the debug backend, it feels like some sort of, like, Zig runtime initialization does not run, right? That's how it feels, because it's like all of these seg faults come from us trying to access, like, global memory that, like, ends up uninitialized, right? Right, like, stood heap page allocator, his context is undefined. It's like, why the fuck is that happening? You know what I mean? So I would like to maybe see if we can figure out where that's supposed to get set. How does the C part use a Zig part? OpenDL or dynamic linking? So it's like, it's kind of like, we have VLC, we have lib hello, right? .so. This guy has two parts. He's got, like, the, like, C glue, and then the C glue calls into the Zig code here. right? So VLC, I think DL opens this. So there's probably some sort of like initializer functions that are in this thing. Probably. I'm actually not really sure. I'm not really sure like how Zig runtime is supposed to start. But yeah, this DL opens this and then calls into like our C glue, and then the C glue calls a Zig. All right. So I guess how can we debug this? We build with LLVM maybe, and maybe we can breakpoint at like memory access. So you don't have to rebuild libhello every time you rebuild the Zig part. I mean, libhello has Zig in it. Libhello is like compiled C and Zig, so I do need to recompile it every time. That's where like the code lives. It's just like this, right? Because like both the C and the Zig compile into like the same like machine code type shit. Yeah. So what I want to do is I want to see if we can maybe set a watch point on maybe like the page allocator. I think that's where we were falling over first, and we could kind of see like who sets that guy. However, it's very likely that like nobody sets him, and he's kind of just like in like already initialized by the linker. There's like a non-zero chance that that's the case, right? Although I guess the page allocator ends up in like, it's probably something like you have your like lib hello, right? This guy, he inside him has like constants, right? And what happens is we load this guy into like process memory, and there's usually like data section in memory and BSS, if I remember correctly, where this is like mutable and this is not mutable. So this is like this is RW type shit. And so if I remember correctly, what I expect to happen is that like we copy over like the initial state into here, but that might not be right. It might also be that like this guy is kind of copied from like a BSS section here. He might be like kind of like mapped into this place with like copy on write or something. I'm not really sure. I don't know how this works. But they're both mutable. Data is initialized data, BSS is uninitialized. Is that true? I'm not 100% on that. I'm not 100% on that. Let's check. Let's check. Cat proc pgrep vlc maps. And can we is this helpful? Probably not, actually, because this won't tell us what section is which. I guess it's more like read elf dash help read elf. There's something like where we can see the sections. Segments, maybe? Yeah, there's section headers and sections and segments. I don't remember which was which. We'll see. So we have segments. Here we go. Here we go. So we got data coming in as... Oh yeah, you're right. Data is writable. You are right, I think. I think A stands for access. W stands for write. So some stuff is... I'm actually not sure. I'm not 100% here, but it does look like that. Where text is not writable. Something like this. A is allocate, I think. What does that mean? Like, oh, I guess like you need to put some space in the binary for like in process memory for this. So like there are some sections. Oh, right. RO data is the thing I was thinking of, by the way. So there's RO data, data, and BSS. BSS is uninitialized static memory, data is initialized static memory, and RO data is read-only static memory. Got it. Got it, got it, got it. Okay. So what I was hoping was that I could put a breakpoint somewhere. So I guess like I want to hopefully there's no like relocation here. That would be annoying. There probably is, which makes this a lot harder. What the fuck? Where the fuck am I? Hello? Wrong window, I guess. Here we go. Where am I looking? I'm looking in plugin.zig, and I'm looking to set a breakpoint somewhere. I don't know where yet. Probably like on init. Probably on like GPA, like general purpose allocator generation. Yeah, something like this. GDB or like run GDB. Can we breakpoint here? And then also can we set like file I guess I need to run like which VLC, I guess. So it's like this guy, and then R. Something like this. Oh, but we also said you set the plugin paths. Oh, and then we also want to do this. Oops. There we go. Streamer. There we go. Something like that. Okay. No breakpoint hit. Why? No breakpoints. That would do it, huh? Can we be main, I guess, instead? Yeah, I don't understand. Maybe it's in the logs. Oh my god, there's too much stuff happening. Too much shit happening. Does he get mad like the breakpoint isn't settable or something because plugin.zig doesn't exist? Oh, answered no. How do I make this answer yes? Can I say like fucking take that shit later? Or do I have to load the shared module first so that it knows? Probably, right? I guess. Forest condition. I don't think that was it, but we can try it. What's he pissed about? Was it the other way around? Oh my god, everything sucks, man. Everything sucks. Yeah, can we do? Okay, I'm just gonna fucking ask the idiot. I'm gonna ask the fucking dumb fucking idiot. Using a script from GDB to set up my breakpoints, can I make this answer yes instead? That seems right. Set. Help. Help. Where would I find this? Data? No. Help set. Oh, here we go. What did he say? It's pending. Help set breakpoint. Set debugger's behavior regarding pending breakpoints. Nice. Set breakpoint pending. Then I say like on, yeah. I believe him. I believe him. Always believe the idiot. Nice. There we go. That's what I was looking for. That's what I was looking for. Okay. So now what I wanted to do was I wanted to look for like a watch point on like stood heap page allocator. Is this like a thing that's in the debug info? No. But we can kind of figure it out probably. How? We like step into this, I guess. And he's eventually going to try to allocate something from the page allocator. Eventually. He's gonna like keep going. Eventually. Probably not here. I probably don't want to be in mutex lock, to be honest. Let me out of here. Let me out. Let me out. Let me out. I don't care about mutex locking right now. Let me out. Wait, did we... Oh, here we go. Backing allocator log raw alloc. Let's go. Let's go. This is where I want to be, baby. Heap page allocator. Okay. Can we... So, I guess the, like, context for this guy... Where the fuck is this coming from? I guess this is coming from... in general purpose allocator? When I do this... When I do this assignment, I feel like he's supposed to get page allocator context here. Right? Because if I look at this guy, we have backing allocator starts as stood heap page allocator. It's what you call allocator? Well, no, because there's two contexts here. There's two contexts. There's one is the, Okay, so there's like general purpose allocator. He returns an allocator, right? And this guy has a context. And so like you are correct that this guy is generated when we call allocator, right? Because he makes this struct here. And this context points back to this guy. But he gets his memory from another allocator, and that's the context where I was confused by. It's that, like, eventually he goes like, oh shit, I need some memory, system, can I get some? And he calls backing allocator get some, and that's the context I was confused about. So it's actually kind of more like here. Yeah, this is interesting. It's not easy for me to set the watch point where I'm trying to set. Because here, when we, like, assign this guy, we go like, hey, could you go to stood heap page allocator? And we copy from this thing. And it seems like it's hard for me to get the source address of this thing, because like stood heap page allocator is not a symbol that's like resolving in GDB. But we could try at least. We could try. Let's just poke around and see if there's anything that we can extract from this guy. So he's doing a mem copy. Compiler RT, by the way, is an interesting thing to have in our brain as like something that exists. Okay. And so like all he's doing is mem copying from this location. He is mem copying 176 bytes from this, okay? And then if we look at like ret global GPA. Oh, that's annoying, dude. That is annoying. Maybe that we're missing something. Right, because we have this guy. Maybe this is what I'm looking for. P this. No. Okay, but that's okay. We can at least look at this guy, maybe? Can we cast this to a general purpose allocator? Even that's hard because the types don't match up nice. Oh, okay, that's fine. Can we at least, maybe we can do a dump of the memory? GDB print memory at address. Can we do that? I kind of want like a fucking like hex dump style thing. Does GDB have a hex dump style memory dump thing? I think there is. I just can't remember what it is. Yep. Just X. Help X. Yeah, great. X. I guess like some X's. And I want some sizes as well. So it's a repeat count followed by a format letter and a size letter. So I'm like, give me like 100 size 100 bytes formatted in hex at this address. No, from the source. This is the more interesting part. So in here, do we I mean, it seems like this is probably the relevant info, right? If we go back down to context somewhere, we see this 7F, FF, F7, blah, 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 A8, right? Do we see an A8 anywhere in here? No. Well, that's interesting. I would expect to see that information somewhere. Okay, what about the stuff at the destination address after we initialize? It's the same thing, which makes sense. Can we fucking print this guy? Like, I don't understand, like, how... Yeah, that's annoying. That's annoying. It's like the information's there, but not in a way that we can, like, query it, which is, like, fucking annoying. But I guess if we go in here somewhere, as we step a little bit... Now we do have this. Fuck, no we don't. Somewhere we're gonna end up with a pointer that we care about. Here we go. P self. P self. This is all I was looking for. Oh. Oh, maybe that was on stack. Wait, do we have this 1.8? We do. Here is the thing I was looking for. The V table of the page allocator, this. So this allocator V table is in the memory of the source where we're copying from right here, right? Which seems fine. His pointer is 0. This seems reasonable. Okay, so now the question becomes, do we see this, does this look the same-ish when we compile with the debug allocator? Or not the debug allocator, sorry, brain. The self-hosted backend. Oh, fuck. Oh, no debug symbols. No debug symbols with the self-hosted backend. Oh, I forgot. That makes everything so much harder. Yeah, that makes everything fucking harder. I mean, I guess the fact that we're ending up in heap page allocator is interesting. That is interesting. You know what I bet it is? I bet you that LLVM is 0 initializing the data section, and the Zig backend is A initializing. You know what I mean? Okay, so if we breakpoint on heap page allocator alloc, or if we end up back in this page allocator alloc function, I bet you we'll see a 0 here for context, because I think that we saw that a second ago. Right, so we end up we're stepping, oopsies. We're stepping. We're trying to get into the page allocator. Eventually, he's going to get there. Where was it? It was here somewhere. Here we go. Boom. 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 What the fuck? This is confusing. Oh yeah, here we go. This is what I was looking for. This is what I was looking for. So here we're seeing context 0 and 131072, and in the debug or in the self-hosted backend, we are seeing page allocator alloc. Can we this, right? So the size is actually the same. The size is actually the same. It's just the context is different, and this is a pretty good clue as to what the bug is, right? A pretty good clue. It should not matter for page allocator. I agree, but the fact that we're segfaulting means that he's accessing someone who has some unexpected behavior, right? And my suspicion would be that there is something that is expected to be 0 initialized that ends up being undefined and A initialized. That would be my guess based off what I'm saying right now. However, maybe that's just a red flag. Could easily be. Are you a full-time streamer? It depends on what you mean by that. I do not stream for 8 hours a day. I do not stream for 40 hours a week. I think I do more programming for stream than I did at my full-time job before. I'm currently unemployed. So by that metric, yes. But I make let's see, if we did a ballpark, a tenth the money that I made at a normal job. You know? So and I don't do it for 8 hours a day. Although I would maybe argue that I spend more time working on this than I did at a normal job. However you want to read that. Are you neat for fun? What the fuck does that mean? Is that some sort of finance acronym? Neat. It's gotta be, right? That's... Hello? Not in education, employment, or training. That makes more sense. Dude, this is crazy. That's insane. But I guess probably yes. Unemployed and not receiving education or vocational training. The classification originated in the UK in the 1990s. Used to spread to other countries. Hey, I live in Canada. Look at that. It's got our little flag and everything. Neat category includes the unemployed. Well, I don't know if I'm unemployed, as well as individuals outside the labor force without a job and not seeking one. It depends on if you consider this a job, which I think I do. I call it work. Come entrance, thank you. It is usually yeah, maybe. I would classify this as a job. Maybe, unclear. I think that the distinction is unimportant, is what I would actually say. Let's see. What I would actually say. Anyways. I guess I should just answer that question next time with yes. I should probably just say yes next time. Yes, this is a full-time job. It's like easier, but I don't like lying is the problem, and I feel like that's a lie. Unless it's funny, then I really like lying. But like in this context, I don't want to lie about it, which is why we've gone down this fucking rabbit hole. Okay. So can we look at like the where we're actually segfaulting? Maybe just a job and skip the full time part. Yeah, that would be, I think, less untrue. All right, he's segfaulting in this map function, and I guess we have no idea where because we're missing debug symbols. I wonder if we can get them though. Because, like, it does emit debug info. We looked into this before. I can't remember what we decided. Was anybody here when we were looking at the like custom LLVM, the custom LLDB for Zig? Did we just give up because compiling LLVM took too long? That's probably what happened, right? Is just like we had to recompile all of LLVM. We just like fuck this shit. Is probably. I typically see neat use an insult. I would say some people probably use it that way, but I didn't think that it was when you said it. Yeah, it took too long. Yeah, okay, that's my regulation as well. Is there an easier way to like debug this then? So we can we? I guess we can bisect with a little strace here. We can tell if we hit the mmap syscall, and if we don't, then we have a pretty good clue about where, like, the segfault's like somewhere up here, right? Could easily be something like this. Yeah, let's hit the strace here. Let's hit a little strace and just kind of see what happens. VLC plugin path is puwd zig out lib. And then can we do strace dash probably follow forks. And we're probably looking for which VLC with the arguments of our fake Stranger Things movie. Oh, but you use LVM false. Segfault? Hello? Oh, maybe I have to build. I do have to build it if I want to. Okay. So the question is do we see an mmap call in here? We do see this one. Is this the right size? It's about right. Approximately, right? I guess it's hard to tell because there's gonna be mmap calls other places, right? Like, people are gonna be calling this shit. But this... Okay, let's see if we can at least... You know what, like the... Can we do like a right syscall? So like the formatter doesn't work, that crashes, but I think that we can probably do like a POSIX right just to like force something visible in strace before here. You know what I mean? What is standard out? 0? Hello? You know what I mean? Can we like do something like this? You know, hello. Okay, wait, so this is good. So we know that PID 63 is the interesting one, which makes this mmap not in the right PID, which is interesting. And we do see the segfault in 63. So I'm assuming that this mmap is not the right one. However, it is showing up at like around the right fucking time. Oh no, but here, okay, nice. Okay, here we're getting somewhere, right? So here we're calling right, hello, wonderful. He's calling get thread ID, and then we segfault somewhere after that, right? So that gives us some clues. I don't know what the clue goes to, but so I think that this query page size thing ends up, I think this is probably the get thread ID thing. No, where is this get thread ID thing coming from? Oh, probably there's like a thread local thing, maybe? I'm actually not sure. Oh, here, maybe. Cached result. No. I actually don't know where that's coming from. Interesting. But we know we're never getting to the mmap syscall. So then the question just becomes, who's getting mad? So probably not this stuff. We're not Windows. Can we just, like, hack the standard library? Is that a thing we can do? Can we copy paste the standard library and inject our own shit into it? That would make everything way easier to debug. Way easier. Because then we could just start logging. Because we can call write. Let's do that. Because I think standard library. Is there like a way to override standard library path? I think there has to be. There has to be. Zig libdir. Here we go. There we go. Okay. So, I guess we just like copy paste the standard library somewhere and then fuck it up. So I guess if I just like jump to definition somewhere, that will tell us where to go here. So probably we copy paste this whole directory somewhere, I would assume. Maybe one level up. All right, let's see what's in here. Yeah, it's probably the Zig folder. Okay, so now can we just start like getting crazy in here? What are we looking for? We're looking for keep page allocator in here. And we're just looking for stood POSIX right, hello 1, right? And we just huck this a few places. This is a sane way to debug, for sure. So we are fairly confident that we're not getting to hello 5, so let's just kind of do this. Okay, zig build, and then was this like zig lib dir zig lib zig, probably. Nice. Okay, good news. I guess all of these tries goes away. So good news is that it's compiling our code. Hello 5, I missed one. What? Oh, I forgot to exclamation point. All these things are write protected. We probably should throw some new lines on here. Okay. Boom, boom, boom. Okay. And then can we not strace, I guess? Since, what? What? Oh, I removed the VLC. He's trying to run the file. Oops, my bad. Okay. So, is it before this one even? Am I crazy? Whoa, hold on. Hold on. I'm getting duped. It's somewhere else. General, okay, let's get to we need to go plug in Zig. Uh hello route 1. Do 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 do. Okay, there we go. Okay. So, it's not in there. That's interesting. I thought that we were in when we compiled before, we were seeing the seg fault in page allocator map, which made me assume that we were getting there, but these prints are saying something else. So it could be that like code is getting like combined and the debug symbols aren't really like pointing to the right place. That seems like very likely actually. Uh so let's kind of just start fucking poke around. Oops, we're in the wrong place because we're looking at the wrong standard library. So I guess, can we go to general or debug allocator as it's called? And then he's calling Alec, this guy. Are we getting here? Hello, GPA 0. I want to see that bad boy at least. Nice. Nice. Okay. Now, what are we looking for? We're looking for references to the like page allocator or something. I guess let's just see what we're getting here. Let's just get fucking crazy. Let's just get fucking crazy out here. Good news. Okay. So now this is getting even more confusing because now we're getting into this raw alloc. Right? So we are getting into page allocator. Maybe I'm confused and we're not in the right one. If OS and OS heap and OS heap page allocator, we don't. There's no way we have OS in root, right? Because this is looking at like plugin.zig for like OS is a struct here, right? And then we're or like a root, like this is looking for like OS a root, maybe like stud OS options, maybe. I actually don't know, but this looks like some sort of override, right? So it seems pretty unlikely. So I assume that we're not WASM, we're not Plan 9, so it has to be this guy, right? It has to be, which lines up with the V table we were seeing. So then, like, how is this not happening? Like, what the fuck? I guess this is the trick. Right? It's just gotta be this is the problem. Can we print can we do formatting right now? I feel like std debug print is broken. I feel like we saw this somewhere. But we can look. Like, what the fuck is this guy? I think that this will now fuck everything up. I think. But we'll see. Yeah. So now he's seg faulting before this, so that's no good. So I guess now it's unclear. Is there a way to like format this stuff in a way that like I think it's in this actually, if I remember correctly. I actually seem to remember. Like, hold on, let's run with GDB again. We might get some more clues here. Maybe this is an easier thing to debug. Oh. Hold on. Wrong. Zig lib dir is zig lib zig. Boom. There we go. So he is... we don't have much information. Just he's in debug print. We don't have a ton of information. But I am kind of willing to bet that it's in here somewhere. Can we... GDB... we can't breakpoint on fucking individual lines. God fucking damn it. But I bet if we do this... Oopsies, wrong one. Debug zig. I'm curious if we just kinda... Fuck. We can't do this, huh? Fine, we'll try something else. Var buff is some space. And can we do std format buff print into this thing? Maybe this is allowed. Because I assume that this doesn't require any globals. So I assume that this will work. And then we can kind of do write with this guy. He probably needs to be null terminated, right? Probably. So let's try that. Let's see if that's allowed, you know? Fuck. Surely this is legal. Because we did a buff print z. Fuck off. Okay, wait. Huge. Look at this. Look at this shit. We got some fucking prints, baby. We got some fucking prints, baby. Okay. So, what do we got here? We got a pointer. We got a V table. Like, this all looks sane to me. Right, so we know that the V table is fine, which means that we have to be getting into this alloc function. Right? Well, I guess we don't know that this is the right place. I guess that's unclear. So I guess maybe we try to print this address and maybe he'll be like, show me what's there. Like, is this close? 7FFF 703 FAEA. ADO? Okay, so he is going there. He's getting into the page allocator. Wait, how much more confusing? So as far as I understand, the first thing our page allocator alloc does is he says hello. So like, What the fuck? Maybe we're in a realloc? Raw alloc calls vtable alloc. Like, hello? Hello? How is this not fucking printing anything then? Did I put... It is 0 for standard out, right? I'm not fucking high? Yeah, 0 here. Am I fucking high and stupid and dumb? Like, what the fuck is going on? Hold on. Disassemble. Like, hello? Whoa, 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 wait. We should have been doing this from the start. So this is our POSIX right. Whoa. What the fuck is going on? What the fuck is supposed to be R9? So, okay, here's the bug, right? R9 empty. Him trying to fucking store RSI in R9. Who knows why? What is like... Who even knows if this is following the calling convention here? We don't know, because like Zig is free to do whatever the fuck he wants internally. But let's assume that he's using, you know, our standard x64 calling convention. Shut the fuck up. No, I'm trying to click the X, man. I'm trying to click the X so I can fucking see. Sorry. System V, this is the one. So, arguments 1 to 6, R9 is the last thing, right? R9 is the 6th integer argument according to this thing, if that's what we're saying. So I guess, can we look at the signature of this guy? What am I looking for? Page allocator. So, and we're looking for like the alloc function. 1, 2, 3, 4. 4, but there's like an implicit argument of the error return, but there is no error here, so never mind. Unless maybe like getting down below. Nah. So he might just be using R9 for shits and giggles. That's not impossible. Not impossible. Can we make some guesses about what the fuck this guy is trying to do? So, RSI would be the second argument, if we're following, which would be the size of the allocation. Does that line up? RSI... No, that looks like a fucking address, right? It looks to me like the size here is this one, if I remember correctly. That looks about right. So that's the fourth argument here, if we're following calling conventions, which like who fucking knows. RAX is the context pointer. Yeah, I mean, it must just not be, right? Because we know... Like, we know that... Oh, here, okay. We do know that N is 131072 here, and we know context of this. So, like, by this, we have some clues as to what the first 4 arguments of this function should be, right? So... Is there a 17 in here at all? No, that's confusing. But I guess maybe it's because we're like a little bit into the function. Can we breakpoint like off rip here? Like just... Fuck. Fuck. God damn it. Okay, unlucky. Unlucky. Can we... Oh, but we can recompile this and just inject the breakpoint command ourselves. Right, we can just be like, fuck you, bitch, sorry. I'm gonna do what I want. If we, in here, huck a little breaky pointy at right here. That should give us something. Oh, except for the fact that this is used. God damn it. If has decal root do alec BP or something. And then can we do in plugin zig do like pub const do alec BP is true or something? Like is this allowed? Let's see. Oops, root here is like this. How do they do this before? Has decal root. What is... Oh, root is import root. Okay. Nope. Interesting. I guess that doesn't do what I want for some fucking reason. If, can we... I mean, we might not even be getting here, right? I actually kind of want to test this somewhere else. Right, can we go back to the debug allocator as well? Oh yeah, maybe we just breakpoint here. I don't know, man. Okay, here we go. Received Sig Trap. Let's go, baby. Let's fucking start Okay. Sig Trap. So this is in the debug allocator. So we're going to be at some call instruction soon, I hope. So we're at 498. Where is that? 498. Wait, what 3498? So we're here. And we are hoping to get into this call probably. I would assume. Right, we're trying to get to what I assume is 3584. But who fucking knows, man? Yeah, there's no like jumps or anywhere in there, so let's fucking run it for a second. We need to go like another like 15 or something. Jesus. I need to... Oh, fuck. I was trying to remember what the call was. God damn it. E4 or something, was it? 3-4, F4. So we're looking for 3584. 3584 is what we're looking for here. We're getting close. Okay, this is the call instruction. All right. step in. Now we're fucking finally at the right spot. We probably could have just put a fucking breakpoint at this address, actually. We should have done that. But, okay, so now we're at the start of this function, and we're looking for clues that we understand our input, right? So, like, here, he thinks that he has... Oh, this is interesting. That's not what we saw before, by the way. This is, like, fucked up. Maybe he doesn't, like, understand until a few frames in or something. I think we were expecting to see a 17 somewhere for alignment, which also is wrong, by the way. Like, now that I think about it, alignment of 17 is insane. Like, fucking batshit. Oh, unless alignment is an enum, which it is. But still, we should be seeing something in the range of, like, 0 to 5. Okay. I don't really know what we're looking for yet. And then also, interestingly... I don't know yet. We were kind of hoping that we would get a clue as to what we think this guy's doing, right? So this is stack pointer management, right? He's like, yo, let me preserve the top of my stack. Let me make some stack space for here. Let me store the current racks variable into the current stack pointer. I think that's the way this has to go, right? Unless it's going the other way. I can't fucking ever remember with this AT&T syntax. Which way is which? Which way is which? Move instruction will move hexadecimal 5 into AL. So it's like source dest. Right? So here he's putting racks into the stack. Here. I think. Yes. And then, interestingly, after he does that, this changes. So keep that in mind as well. So it looks like maybe these variables the debug thing is expecting to have on the stack or something. Okay. So info registers, we can double click this as well. We can look at racks is a, and then we can also check that the thing at the top of the stack is also that now. Right? Okay, cool. We understand. Okay, so then he's throwing some more registers. What is BL? Is that a register? What the fuck is that? What the fuck is BL? I don't know what that means. But sure, he's putting some other stuff on the stack here. And so then at this point, it's literally just R9 untouched. It's the lowest 8 bits of RBX. Oh, right, of course. So here he's like, okay, now let me dereference the thing in R9 and put in RSI, and R9 is like completely unfucking set. Right? This has nothing to do with us. Interesting. So this is like more confusing, right? I guess it depends on where R9 is supposed to come from, but this doesn't look like initialization, really. I guess maybe R9 could be like some like error context or something. Could be. But this explains why we're crashing before we print anything, is because this is in like function preamble. Okay, so where is this supposed to come from? I guess we go up a layer. So is R9 set anywhere in here? Okay, so this is interesting here. The debug allocator does the same thing. So can we breakpoint here? And maybe that will give us a clue? Maybe? Like, if we just breakpoint at the top of a function that does fucking work, that can give us some clues at what we think this thing is supposed to be. Oh, we need to do the same, like, if... Fuck. We need to do the same, this thing, so that it doesn't break normal compilation. Okay. So, P are info registers, I guess? R9 here is a thing on the stack that looks like? Can we look at what we think this thing is? Like, can we do... Give me 16 bytes of this thing? I mean, it's like another address of something. Which looks like this. No? Oh, no, wait, hold on. I don't know. 07F, FF, FF, FE, 0780. What's in here? Not really anything obvious, right? Nothing super obvious. But it does look like R9 is like a thing on the stack, right? That's kind of like the trick, the like thing we could look for. And then it's pretty clear that somewhere between here and there, R9 is going to get loaded. Can you like break on register load in GDB? Is that like a thing you can do? Is the idiot still around? No. Can I set GDB watch points on registers instead of on memory accesses? Like, I want to know if someone modifies R9. You know? Is that a thing I can do? He might say no. Not with a hardware watch point. Use a software register watch point. Yeah, okay. He's just telling me to fucking do it myself. Fuck you. The answer is no. Okay. Then we have to get a little fancy with it. We just gotta look. See, what's so confusing here is like when I search for R9, the only thing they do is like put R9 into places. You know what I mean? Like they never like fucking change it. You know what I mean? But he's clearly nulled out by here, so by like the next breakpoint. So I guess can we like set a couple more checkpoints? Right? It's like somewhere between here, he's getting like fucked up. Let's just like throw a couple more around, I guess, because we're like fucking stupid. Because otherwise we can't figure it out. God, I hope you can't do that. Yeah, I mean, I think that's fair. I was thinking, like, you know, you could single step and watch, which is fine, like a stupid whatever. Or you could, like, I thought there might be, like, a register instruction, like a CPU intrinsic to do that, but I guess not. Okay. So, first one, we're chilling. Continue. We hit another sig trap. R9 is cleared. So somewhere between the first and the second, which is good. There's not a lot to look at, right? It's like somewhere in here, it's getting fucked. I guess it could be like as a result of a function call. You know, I guess someone maybe is not preserving this correctly. Like, if this guy, is he doing any like C, like when he does Futex stuff? Is he going into like libc in some way? Like, what are my impl options here? We have Linux. I would assume we're in the Linux implementation. I would assume that we're going here. In which case, like, like my new concern is that like some C libc function is like using a different calling convention or something, you know what I mean? And like as a result, we are losing some register that we're not expecting to lose. Right? I don't know what R9 is yet. I just know that like no one in this function is expecting it to be set and there's like they're expecting it to keep going. You know what I mean? You know what I mean? I wonder if it's worth comparing the function prologue with the LLVM backend. You know what I mean? It might be. It might be. Right? So there is a clue here. Where we do not see the same thing. You know? R9 is Ronaldo number 9. Thank you. Right? So there's something there. He's allocating his registers differently, which is like completely reasonable, right? It's a completely different fucking backend, so why would we expect them to be the same? Unless it was like a calling convention thing, but it's not, right? It seems like. So that's a clue. And so if we can figure out what this guy's purpose is. So I'm just trying to think of like a few ways to debug this. I want to see what happens if we are not a shared library and we follow a similar code path, right? Can we do like test zig here and do like a pub function main, right? And in here, can we just do like basically the same thing, right? General purpose allocator is stood heap general purpose allocator alloc is this, and then can we do alloc create some like structure? Maybe just like an alloc of 100 bytes or something. And then can we do... I'm just hoping that this will actually trigger the code. Maybe we do this. And then can we do like const test exe is b add executable. Root module is b create module. Target is b graph host. Optimize is debug. Root source file is b path of whatever the fuck we just said. Test something. And name is test.exe, something like this. B install artifact test.exe. Okay. What's he pissed about? I guess this thing does need to be var. So true. Okay, are we chilling? Okay, I think we're chilling. And zig out bin test exe. Cool. We hit our breakpoint. Now, what I'm curious about is if we link libc here, does that like fuck everything up? Because like there's a good chance that it does, I think. You know what I mean? It really, like, this will help us bisect the problem to some extent. I'm hoping. Okay. So this guy did work. Can we, like, get our internal traps as well? So we have, like, pub const do, what was it? Do alloc bp? Okay. So, okay. Interesting news here, right? We do see the same prologue now, but in this context, it seems like it's like reasonable. So maybe we can like start trying to bisect, like we can see what the difference is, right? So here, R9 is like a reasonable thing on the stack again. And so can we also confirm that when we run this guy and we see our first sig trap, we see our second sig trap, my suspicion here is that R9 is not getting cleared, right? So there's some difference between when we compile this thing as a shared object and when we do not. Or when we deal open this thing and when we do not, right? There's some difference in how that register is getting preserved. Oh wait, are we in a different function here? We are. We're in alloc instead of alloc create. So this isn't a one-to-one comparison. Plugin is equal to, can we do like, can we just copy paste it? So that it's like actually the same? I think it's easiest if we do this. Const plugin is import plugin zig, and then we just use plugin. Okay, so now this should be one-to-one, I think. Why I'm at a computer today? Because when what we were trying to do is we were trying to work on the VLC plugin, but then compilation was taking a little bit too long because we had to use LLVM. And then we're like, why the fuck do we have to use LLVM? You know? And so we've gotten like super fucking sidetracked, but that's okay. That is okay. Okay. Yes, okay. I think that this is a fair comparison now. So where are we right now? We're in debug allocator alloc. And we are at our second sig trap that we injected, right? So we're at this break instruction 418 in. 418 in. Okay, now let's compare that with the plugin version. First sig trap, second sig trap. Why does he know where he is? Are we compiling with LVM right now? Yeah, we are. My bad. Okay, first sig trap, second sig trap, and we think we should be somewhere in like the 400s in 419 in. So we were in the exact same spot, okay? But our like register 9 has been clobbered. So the big question is what is the difference that is causing that to happen? So I was hoping that we would see this in both versions. I thought that that would like give us a clue that it's like something about like libc doing some like wacky shit, but that's obviously not the case. But that's okay. We will get there. We will get there. Maybe. Maybe we won't. Maybe she's born with it. Maybe it's Maybelline. Dude, some ads are so fucking effective. Like, I just heard that jingle like on children's TV like 20 years ago, and I just still think about it every time. Every time I think the phrase maybe something, I immediately start thinking maybe she was born with it. That's crazy. They fucking nailed my brain forever, dude. That's crazy. Okay, so I'm gonna assume that it's this mutex lock. I think that is a sane assumption, but let's just double check, because like what else would be doing it? You know what I mean? You know, info registers R9 is fine. He's got some shit in him. Hit continue. Now we're just after the mutex lock, I think. Info registers. And R9 is fucked, right? And if we look for the little arrow in here, we should be right after mutex lock. Good. Good. We have our first like actual real lead, I feel like. Linux. Impl, how do we do this again? Ooh, wait. Hold on. We could very easily be in different implementations here. Single threaded, like we don't know if maybe compiling as a shared module changes things here. You know what I mean? Can we just start like fucking stepping? Maybe that's the play. Where are we at? We can't single step like that, unfortunately, but we can do step instructions and just kind of wait till we end up in a you know, in a mutex lock somewhere. Oh. Wait, hold on. Is this the same thing that we're seeing in the executable? Hold on. Are we in the same... Oh, we are. We are on the same path. Okay. Peak DevX, yeah. I guess we can just print it, right? Or we can we even like print what the impl is? We might be able to. Zig might be nice enough to let us do that. Can we do something like... Can we do something like... Tell me what up with self mutex impl. Just tell me what up, buddy. Fuck, I just quit instead of fucking saving. I'm an idiot. Debug allocator. Buff print. Okay. Bring this guy up here. What up with yo mutex? Bum 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 bum. It's not that helpful. Not that helpful. Can we see if we're single threaded? That will at least help us figure out something. False in the exe. What about when we... Wait, hold on. Yeah, false in the executable. What about when we run VLC? False. Okay. So we are not single-threaded, which means that our mutex is probably... I don't know. So we're not single-threaded. We're in debug mode, so we're in debug impl, and that lines up with this guy, right? This like locking thread and impl thing. And is, oh, I see. So the only difference is that the release impl is used inside. If single-threaded, single-threaded. We're not single-threaded. So we must be in futex impl. We gotta be. So when he locks, he's doing this stuff, and I guess we just keep bisecting. I think it's likely. Like, get current ID sounds like something sketchy, but I guess we can just see it, right? Let's just we just do the same thing, where I wonder if we could get like a print R9 function somewhere. Right? If we just that would be convenient, because then we could just start logging it over and over again, right? Can we do something like plugin.zig? Can we do log R9? And we're trying to avoid using anything like standard. We're trying to avoid using std debug print because there's a lock in there that was just crashing. So we're trying to do like a raw write here of buff. We have buff here is, you know, a page of shit, and we're gonna do our std format buff print, which we know is okay, of R9 into this thing. And then the question is maybe a hex, like this. And then can we also get away with doing something like tag here, so that we can kind of do something like this, where we have like, we can kind of start logging where we are and what the value of R9 is, kind of around there. And then all we have to do is do some like inline ASM, which I don't fucking know, man. Looks like it's the same shit as like the GCC stuff to some extent. However, we need to look up what like the flags are for this. Zig lang ref. Right, because really we're not actually trying to do any we're not actually trying to like write any assembly. We're just trying to like get it to yoink out the variable we care about, right? So it looks like it's probably something like this, right? So they have inputs here. Do they have an example with outputs? So this is like what values are being... He's got return in here. He's ret. He's like, I want to clobber RAX with a usize. Here he's got like tags in here of like how he wants inputs to get set. You know what? This feels sketchy to me. Example here. Nice, nice. Good fucking eye. This is exactly what I want. So he's just got 1:, and then equals probably means clobber, which is a little scary. Maybe not. Well, we'll see. So here we kind of just want like R9 is like equals R9 or something, right? Into R9. One of these is in and one of these is out, right? So based off this, This is probably a name that you use inside that is being discarded. And then this is probably this is coming out into R9 would be maybe my guess, unless this is special for return variable, which it might also be. So maybe it's like something like this. We could check that we can check by doing we know that it's going to be broken in debug allocator. So we can do root log R9 GPA 0 or something, right? If has decal root log R9 like this. And then let's do it twice at the beginning here and then once after. And like, let's see if that shows us what we expect to see, right? He does not compile, I think. Error union is discarded. So true, man. So fucking true. It's so true right now. Just fucking crashes my shit up, dude. And I guess we probably need this in test.zig as well. Oh my god. And this is to be buff print z, and this is pointer cast of s. Is what we learned last time, right? Something like this. Oh my god. Fuck you, man. Why not use GDB commands? Just because how do I say this? The debug. So we're trying to debug the self-hosted Zig backend, right? The self-hosted Zig backend does not emit debug info that GDB can process correctly. And so we are trying to extract information in a different way. Okay, so this is good news, is it doesn't look like we're fucking up R9 by doing this, and we are seeing the state that we expect to see. This is really good. This is really good. Okay, so now we can just start fucking slamming this log R9 just all over the place, right? And we can just kind of start like seeing where shit goes down. So where the fuck were we though? That's the question. We just want to start like slapping this shit everywhere. Oh fuck, wrong folder, wrong folder, wrong folder. We're in the other mutex, our copy pasted sound library. Fuck. Has decal. What was it? It's like a log R9 is what we're looking for, right? Boom. Oops. Okay. So this is lock 0. Root is import root. And then let's slap these a few places. Boom. 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 Let's just see what happens. All right, we're getting somewhere. Between lock 0 and lock 1, thread get current ID is fucking us up, dude. All right, dude. Impl. Use pthreads. POSIX thread impl. Linux. Get current ID. It's probably here, right? Get TID 0, right? And then this is probably, this is a clue probably. But let's throw this in here as well. Do you use the latest version of Zag? Got a YouTube video that auto changes? I'm on 0.15, which is not the latest. It's like the latest released. I might be on 0.15.1 instead of 0.15.2, but like whatever. Let's fucking go, baby. Let's fucking go. Wait, okay, this is so sick. So, this guy is calling a syscall that is clobbering our register. And nobody is expecting that. But they should, right? Because R9 is one of the arguments to a syscall. But this is syscall 0. Can we look at like what are the expectations? Syscall expectation. System VABI maybe? And then the next question becomes, why the fuck does this not cause problems on the executable? In fact, can we just start like... I wonder if it's because we're in a thread somewhere? Right? Like, it's gotta be, like... I guess, is Linux provided differently based off of if we're using like compiled as like fpic or shared object or something? I don't really know yet. I don't know what I'm asking even. But like, oopsies. Fuck. I didn't fix the new line thing in the other version. New line, right here. Okay, so, oh my god. I have to build. You gotta build the code that you want to fucking run. If you think about it, you have to fucking build your fucking code. Okay. Okay, run, continue, right? So here we see in our executable version, this get TID is not causing problems. Now, can we strace? No, not strace. How do we want to bisect this? How do we want to bisect this? Because this is so confusing. I guess we are seeing in our executable that we are calling get TID as well. You know what I mean? So I'm just going to do like syscall 0. Syscall 0 thinks that the only things he has to worry about here are R0 and R1. And he's calling the SVC instruction. And he is storing R7 explicitly, which is interesting. What the fuck is going on here? Temp here is this buffer. So it looks like what's happening is he's going like, yo, I know I know something that like my syscall, he's like, oh, I need to use R7, and I'm worried that R7 is used by something else. So I am going to write down R7 here, then load my number, my syscall number, into R7, then call this thing. So it must be that R7 is like the register. Is this ARM code? Yeah, that's a good point. That's a really great point. I don't know how I ended up here. Linux x64. That's a really good point. Syscall. This makes way more sense. Thank you. My brain was just like fucking melting my fucking face off. Okay. So here, he thinks the only register that could be affected from these things are R11, memory, RCX, and Rex. And maybe that's just not true. Right? Maybe we just shove an R9 in here and it fucking fixes our problems. But I would like to understand why that's the case. System call is done via syscall instruction. The kernel destroys registers RCX and R11. Okay. User level applications use as integer register for packing the sequence here. Kernel interface uses these. Okay. Is it something like get thread ID actually is like parameterized or something? How confusing. How confusing. Are we, I guess another question is, are we confident that we are in this version and not the C version? Because I really feel like there's like a libc version that could be happening here. Can we throw a breakpoint here and just see if that's fucking getting hit? Or maybe throw our log R9s here. Get GID to something like this, right? Just because I'm not like 100% that this is the path that we're taking. What the fuck? Oh, sure. We'll just put it in this context then. What? Oh, unreachable here. Fine. Fine. Okay. So we are confident. Whoa. That's fucking weird. That's fucking weird. No, that's fucking weird. This is 0 before the syscall. Wow, that's even more confusing. What the fuck? Okay. Okay, so we need to breakpoint here, right? We need to... what is it? It's like, do something alloc BP. What the fuck is going on? This is so weird. Okay. Okay, so the question is, here, R9 chillin', right? And we are... I think we should be right before our, like, call to something. Oh, wait. Are we after the lock? Did I... Oh, oops. I hit continue by mistake. Hold on. Okay. So R9 chillin'. And we are right before this call to thread get current ID. Okay. So jump into get current ID. He's not doing anything, right? He's just going into POSIX thread impl get current ID. So we go over there a little bit. And in here, we are just going into get current ID again. So we slap that a couple times. And here we are at our log R9 here. R9 still chilling, right? I'm a little lost about where we are right now. Hold on. Disassemble. So we are in get current ID. This is in like thread zig Linux thread impl. Where is this guy defined? Here. So I'm confused. Then it's in Linux get TID where it was fucked. So it's fucked by here, but not here, right? That's kind of what we're expecting to see. So we're expecting here for it to be fine. Then maybe it's in this TLS get adder it gets fucked. That's possible. Okay, we go until we see the log. Hello? Oh my god. Can I finish? Does that work? Nice. Okay, so we're about to do this TLS get adder thing. I'm gonna go next instruction here to go over. And R9 is fucked. Whoa! That's even more confusing. Okay. It's this guy. Thread local storage get address. Okay. So I guess we have to go again, I guess. I don't remember where we were. I got lost. It was here. Okay, step instruction. Go this a few times until we get into Linux impl get current ID. Then we're looking for this guy. So this is at F2. I guess we just hit next instruction. We're looking for this, and we start step instruction now to go in. And then what's going on here? Okay, so step a couple times. I'm assuming that we're still good until this jump. Yup. Okay. Oh, fuck me, dude. I fucking accidentally hit continue. God damn it. But it's in this TLS get address in this thing. Where is this? sysdeps x8664. Is this in Zig somewhere? Or is this in... I'm not sure where this is. What file does he think this is? This is in sysdeps x8664. TLS get adder. Not in here. Okay, so this must be some libc code. TLS get adder. Not defined. Oh, it's called this. Okay, sorry. Okay. Wait, hold on. We're getting somewhere. Run. Break. Here. Continue. Continue. Nice. Okay. This guy, what is he doing? Wait. Also, the other thing I want to do here is prove somehow that we eventually we want to reproduce this outside of the shared library, right? That's kind of like the desire here. But let's see where we end up in, like, which one of these guys we end up in. Okay. Where are we at? Here. Wait. Info registers. R9 fucked. Whoa, when the fuck did that happen? What the fuck? Hold on. What the fuck just happened? Continue. Info registers. R9 fine. Does it have a different name in here? Is it FS here? No, that's the wrong way. How the fuck? R9 fine. Oh, fuck. I've pressed the wrong thing. God damn it. Break on this. Continue. And backtrace here. Make sure we're in the right spot. Not this one. Backtrace here. Not this one. Backtrace here. There's multiple threads calling get thread ID, which is confusing. This is the right one. Okay. Disable the breakpoint, just to make sure that we're not getting confused. Then info registers. R9's fine. Okay. There we go. Okay. Next instruction a few times. Info registers, still fine. Next instruction a few times. Info registers, still fine. This is what I expect. That's what I expect. We might have got in, like, some bullshit where we jumped. We might have flipped threads there by mistake. Yeah, okay, I think I got confused. I think we got confused. So we're probably in TLS get adder slow. R9 is still fine, right? Okay, this makes sense. And then in here, we might end up, you know, somewhere else. It's fine, whatever. We'll just hit SI a few times. And just checking in. Still fine. Like, where the fuck are we right now? TLS get adder tail, whatever. Still fine. Can I just finish? I want to get out of this. Okay, he's clobbered by the end of this, like, get adder tail thing. Okay, so it doesn't really matter that much, I don't think, right? We know that we're in, like, libc code for TLS get adder. And we end up in this TLS get adder tail from TLS get adder. Doesn't really matter. The interesting thing here is that this libc code, somewhere down here, probably just calls a function that takes 6 arguments. What are the rules about, like, caller save and callee save? Right? Like, if I use R9 here, is it expected that I back it the fuck up? Can you use Musil? That's a great question. Yeah, that seems likely, right? I'm too lazy to read this spec right now. I'm gonna ask the idiot and, like, kind of tentatively trust him. Because this seems like the type of thing that he should know. On x86 64, if a function is called, like, let's maybe syscall. Sorry, this is the, what is this? System V ABI. Is it expected that when that registers used for, like, god damn it, I fucking hate how Control W closes tabs, but it deletes words in Vim. In System V API for x86-64, were you not again on ARM? Was I? I don't think so. I was at some point, but I don't think there. Is it expected that like, I want to say, like, functions that take take one argument, preserve, do not clobber, other argument registers, i.e. is my function void free to clobber RSI R9? Argument registers, caller saved. A caller must assume these can be overridden by the callee. So my guess here would be that, like, it's not obvious to zig somehow. I wonder if it's like he's missing handling of register backup in thread locals or something when using libc. You know what I mean? Like, if libc's thread local variables or so, okay, the next question we have is, why the fuck isn't this a problem in our test executable? Right? Like, what the fuck is going on here? Where this should be going through the same fucking paths, right? So can we do the same test here? Where we run our little test exe, gdb test exe, break on this guy. Maybe we hit run, break on this guy, which is the same fucking spot, right? That's weird. That's weird. Can you describe the bugs? R9 getting clobbered? Yeah. R9 is getting clobbered from somewhere in the shared, when we run this thing as like a DL open shared object. And that is resulting in Zig trying to reference something that was stored in R9 before down the stack. I don't know what R9 is for yet. But we are seg faulting on an access to R9 that is like unchecked, right? And so like what we see in when it works on our Zig executable is that R9 value is just like still, it's somewhere on the stack. He's happy, nothing changes him. And then when we run through the shared object path, it gets clobbered in this mutex lock and everything breaks. That's kind of like the behavior we're seeing. Okay, so here we see R9 chilling. We break out of this thing. R9's the same as it was before. So the question is what is the fucking difference here? Info or am I break? Oh, I'm not. Oh yeah, I do have that. Del 2. I wonder if we're just not hitting it. Oh, wait. TLS get adder might not be getting hit in this for some fucking reason. I wonder if it's because like the main thread local variables are fine or something. Like I wonder if it's something to do with like a new thread initialized by C. It could be something like that. Right, so it's supposed to be around here, right? Somewhere. We are... Where the fuck are we? In, like, thread mutex lock. We are right after this lock 0 print. And we're at this breakpoint. So where the fuck was that again? Mutex. Lock 0. Okay, then we have get current ID. And then our impls were... Was it in here? Yes. So maybe we're not seeing use p threads if built-in link libc. I mean, this should be happening, but we should just double check this. So we should be seeing get tid 0 here log. Log R9, get tid 0, get tid 1. That's what we're looking for. Yeah, get tid 20. Is that the one? Yeah, okay, cool. So I guess we just want to add a breakpoint here, I guess. And then we need to be careful that we're only doing this in, like, this shit. Okay, here we go. Related to mutex lock, mutex 6 calls unusual. It takes it 6 Rs and 6 is R9. That is definitely, like, somewhat relevant information. However, we have kind of bisected this problem in that it's not actually the get thread ID part. It is the get local storage part, which is maybe under the hood using get thread ID. There is something there, maybe. Or sorry, you're saying futex. Yeah, sorry, we've definitely got out of the futex part. Sorry, brain. Okay. So my question here is, does this look different? Right, I don't see this, like, TLS shit that we saw in the shared library. Hold on, let's check. VLC, oopsies, GDB, GDB-X, maybe. So we're looking for the one after this. Okay, disassemble. Yeah, this looks different, right? So this is in Linux thread impl get current ID. He's calling TLS get adder, right? And then if we run this guy, Linux thread impl get current ID, he does not, right? There's none of that shit. It only crashes when running as a dynlib? Yeah. Could someone recap what the problem is? Okay, so from the top, we were annoyed that we have to use the LLVM backend when compiling our plugin for VLC. We're like, what the fuck is going on? We're segfaulting every once in a while. And that segfault we traced back to in the function prologue of some, like, of arbitrary standard library functions. There would be a storage of the item that was pointed to by register 9 somewhere. And we have now traced that down to somebody, like, the Zig is, like, hand wavy, kind of expecting that R9 holds some value that he was passing at the beginning of some function. And when we lock a mutex, when we lock I think that we've actually seen this. I think it's all mutex related. I think all the places we've seen this Oh no, when we tried to do a std debug print, he tries to lock a global mutex, and I think it's the same with the allocator. I think in both cases they try to lock a global mutex, and in these scenarios, they are using a thread local variable to cache this thing, right? So they say like, hey, I have TLS thread ID sitting here, and in the shared library version of this thing, this goes into some assembly function that does something. And that clobbers R9, and Zig seems to not expect that. And for some fucking reason, when I'm compiling this not as a shared object, that's different. I wonder if it's because it can inline it if it's not using fpic. Yeah, it might be something like that. It might also be something to do with, like, if Zig knows that we're in the main thread, things might be different. Right? Like, so what is that function that we were even, like, getting mad at? TLS get attr, right? Yeah, you know what? This looks to me like fpicky. I don't know why I think that. Could it be related to this? I want to find the bug myself first before looking up issues. So I wanna get to like what I think the root cause is, and then look up what they've already found, because I think that's kind of more fun. There's no solution. Smile. Okay, cool. Then in that case, I will click it. Yeah, I mean this probably is the same thing. Yeah, this is the same bug. This is the same bug. Yeah. This is exactly the same thing. And they haven't fixed it? Wait, so maybe we're doing actual relevant info. That's exciting. Okay. So the question becomes, why the fuck is this different? Okay, let's just start trying like turning on shit. Test exe position. You can do pi root module pick. Let's try this. That's like the obvious major difference between shared objects and shit. So let's just see if this does like something similar. Okay, that's not it. Makes sense. Makes sense. We don't see that little get thread ID thing there, or TLS whatever. Are you compiling with LVM? Sometimes. Not other times. It sounds like a NixOS bug, based on what they're saying. You know what we could do, actually? Is now that we know what we're expecting to see, we can actually stop running anything. Can we obj dump -d lib, maybe we can't do this. Obj dump -d zig lib, sorry, zig out lib hello. And can we look for, what is this? It's Linux thread impl get current ID. Nice. Okay. Cool. So we can just look for this and see if that's the same. So if we compile this as a shared object instead, you know what I mean? And then just to make sure that this thing gets exported correctly, test zig, we can look for pub export function do thing like this, right? And so now this should still kind of compile in the same way. And then we can do obj dump on lib test instead. Oh, we need to be shared object. My bad. How did we make it shared on the other one? Linkage dynamic. Okay, let's do that. Let's do that. And then obj dump with lib test exe. So, and we're looking for Linux thread impl or something. Get current ID. Okay, good clue here, right? In that by compiling this thing as a shared object, we are now getting this TLS get adder thing. And I think we can probably assume that the same behavior is happening. But now I want to bisect the difference between if this is DL opened or like linked proper. You know what I mean? So I think we can make this problem smaller. I think let's work on that. Like really scoping down the use case, which is just we should be able to call stood thread get current ID. Yes. So this is in test.zig. All we want to do is we want to call stood thread get current ID, and let's just return this thing. We'll say this do thing returns the fucking thread ID. You know, fuck it. Yeah. Okay. Get Linux thread impl, I think it was. Linux thread impl. Nice. And then can we prove to ourselves that the same R9 clobber is happening here? I guess it's hard if we don't know that if we're not how do I say this? If like R9 isn't explicitly said somehow, but we can do a fucky wucky, right? Where we can kind of like store R9. I think this is allowed. It's I don't know what like the clobbers are here. Can we look at like the syscall thing? Can you just manually store? Yeah, I guess we can just do the log R9 thing here, right? We can do log R9 before, and then const ret is equal to this, and then log R9 after, and return ret, right? This, I guess, is the trick. This is the trick. And then we want to call this from somewhere, right? So test exe, I guess. And we want to call do thing, right? Where extern, we have like an extern function do thing returns i32. And then we want to call, this is test lib now. Okay. And then can we do something like make a test exe, which is create add executable, and here it's like test exe, and then can we do root module is create module of something that has like root source file is bpath test exe.zig now. Wonderful. Target is my current host, which is wrong, but fuck off. I don't care. We can hardcode it. I don't give a fuck. Test exe link library, and this is test lib like this. And then does that build? That'd be cool if it did. Gray header is linked to a thing in start.zig, but I don't want to look at that yet, I think. I do want to look at that thing eventually, but for now, I want to keep going down this path first. Okay. Zig, oh, bin, test, exe. GDB this thing? Okay. So this is interesting, right? So, how do we do this? Disassemble. So here, info registers, R9 is a value, right? We go next instruction, and we go into this TLS get adder, right? And here, R9 is preserved now, which was not the case before, right? So this lines up with that bug report that was linked, that this is specifically related to DL open. So can we do something? We link libc here, and then can we call DL open easily from our test? What was the case, like, do they have it written down here? Oh, they call it from C. Which I think, yeah, I like that better, actually. I do like that better. So can we actually change this to test exe.c int main void? Let's start with just like the version of this thing that's like int do thing, takes no arguments, and then we call do thing, right? Am I stupid? What the fuck is going on? What did you change to get R9 reserved? Load as like link proper instead of DL open is the only difference so far. Well, there's, I mean, we haven't proven. We're trying to make a different test case now. Sorry, it's not 100% clear. But this test exe.zig now calls do thing in test.zig, which calls the same function, but R9 is preserved. Now, this is like a fairly different context than we were in before, right? So there's a lot of things that could be going wrong here. But if we link against this library proper, we don't see the problem. So now I want to prove that by DL opening, it's fucked. That's kind of like the next stage. Are you sure it's not preserved and not just uninitialized data? It's changing. It's like when we call that function, we see it go from like one number to 0. And when we call it in this other context, we see it stay the same, right? So we'd be lucky. We'd be lucky if it was uninitialized, because the uninitialized data would have to be the same value that it was before. You know what I mean? If I understand things correctly. Test exe, add C source file. File is the path of test exe.c now. And this is gonna get fucked up probably. We'll see. Maybe this builds. Nice. Okay. Out bin test exe. Okay. So now the question is if we DL open this thing instead, which is what these guys did. Zig out lib test lib like this. And their function is very similar to ours. Ours is returning a I32 though. Do thing func or something. We like do this. Do thing func. Func is a do thing func coming from the lib looking for do thing. And then we call do thing. Easy. This should be all the same. I don't know why he doesn't like it. But let's try that. Did I fuck this up somehow? Oh, int. My bad. Nice, dude. Okay. And if we... Why is this seg faulting? Hold on. B main. Run. Oopsies, finish. Oh, wait, this is maybe broken. Test lit, hold on. Hold on. What am I missing? ls. We should have testlib.so, lib test underscore lib.so. Oh. That would do it. Okay, here we go. Nice. Nice, dude. We have the same fucking thing now. We have the same thing where if we link it, if we deal open it, that function clears R9. We have proof of that. Versus if we link, we like link proper. So I want to kind of make sure that we have both of those cases around actually. So can we call this test exe deal open? Deal open. And we call this deal open. Okay. Okay. Test exe.c. So this is now test exe deal open. And then this one, can we undo? Not easily. Okay, so this version was int do thing void like this, and then in build zig we actually like link that motherfucker. So in the deal open version we don't. In this version we do. Okay. Zig build and zig out. Bin test exe deal open before something after 0. This version preserved. Let's fucking go, baby. Let's fucking go. Okay, so I think this is fucking confusing, right? Because both of these guys are just calling this like, they're calling the same function in the same library, right? It's this like, lib test. Is this called lib test lib now? Hold on. Linux thread impl. Right? They're both calling this guy. And their behaviors are just different, which means that like I wonder if the like where this lives is different if you're delopened or something. Or the other option is that like inside him he's doing something based off of that. I don't know. LDD zig out bin. Let's just kind of look at like the difference test exe and test exe delopen. These guys are both linking against libc. Wonderful. You should click my link now. Okay. I'm down. I am down. Maybe. But I don't really think this. So my confusion here is that the part that's the problem is in libc code, right? It's like kind of like completely unrelated to Zig because of the fact that we're using like link libc, right? So we're probably seeing like the thread local storage implementation. Maybe, oh, maybe not. Right, there's something here where the thread local storage is not owned by zig in this scenario because we compare it as a shared object that links against libc or something like that. You know what I mean? I suspect that that's more the problem. And I suspect... okay, if I were to guess, I would say that when we DL open this thing, what does do thing do? It just calls like get thread ID. My suspicion is that when we DL open, this thread local storage thing eventually calls a function that takes 6 parameters. And when we are not DL opened, it doesn't. That would be my guess. Can we look at the libc source code? Or maybe we just you're linking something else. Where are we? What is going on here? POSIX, call main and exit. You're linking something about stood pi. We're like, I believe. So again, more context here. I guess it's possible that this code is still running in through some sort of like lib function, like library initializer. But I will clarify that our thing is coming through C, like a C program, right? So as far as I understand, the Zig runtime is not responsible for this problem. That's my understanding. I haven't proven it yet, but I'm pretty sure Zig is expected to just show up, and it just doesn't. That was my initial thought, but I am less inclined to believe that now, specifically because we see him querying the thread local storage through the libc function. That's kind of like the kicker for me. What was it? Links threadable? Right? This guy's getting the address. The problem here is that he is asking for the address of some thread local variable from libc, and this function is fucking up our expectations of existing registers. That's kind of my understanding of this problem. So I guess I'm curious about how this looks different in the DL open version and the non-DL open version of the problem. I guess that's probably the next play here. So maybe we can do like a... Is the function signature incorrect? I guess I don't know. Yeah, there could be something like that. That wouldn't shock me. However, when we looked at man to... I guess we haven't looked at this actually. What is the... Yeah, that's a really good question actually. If this thing like... Where does this come from? Is there like man page for this, or like a header for this or something? I don't know what I'm trying to look for. What are the expectations of registers? My expectation, assuming that everybody's conforming to system v ABI, the expectation is that R9 is caller saved. Caller saved. Like, so if I'm calling a function that takes 6 arguments, because R9 is the 6th argument register, I need to back that shit up before calling. But, you know, Zig internally doesn't have to use system v API, but in this case, he's calling like a libc function, but the libc function is like a raw assembly function, so the expectations might be all fucked. Like, the expectations everywhere might just be fucked. Who knows? I want to look at the difference between the DL open and non-DL open version, because the behavior is different, and so that's confusing. So can we change this guy to run zig out bin test.exe? And can we break on this guy? And then can we run? Okay. Cool. So info registers. Let's just double check here. We have R9 here, and this is the non-deal open version. So I finish this thing, and my R9 is still chilling, right? He's still non-fucked. But if I change my little GDB script to run the deal open version, and I hit continue a couple times, finish from this function, info registers, R9 fucky wucky. Okay, great. Now, I think that we saw in the deal open version that this was in like the tail function of something. I guess the key here is let's find out where it gets fucked. Right, so we saw it was in some sort of like tail thing. Are we in get adder slow here? Oh yeah, wait, okay, we went to get adder slow, right? That's what we saw just now, I think. I see a call get adder slow, and then info registers. Here, R9 is chill. Next instruction, jump over that thing. Info registers, fucked. Okay, so it's in the implementation of slow. Can we confirm that in the non-deal open version, maybe we take a different path here? Aha! So, in the one version, we end up going slow. One version, we do not. Why is that? Because he's looking at if Rax is full of Fs. If Rax is full of Fs, then he jumps here. So here he's pulling the value into Rax from somewhere probably, and it's like uninitialized in the deal open case. From this guy. Yeah, I don't have like a good understanding of this, but this seems to be the fucking problem. So can we go back to the deal open case? Can we change this guy to break on the slow version? And then run deal open, okay? And we do, in fact, end up in this thing. Now, okay. So this is back in C land. Right? Which is interesting. So we're going zig to assembly to C sometimes. Then this guy, can we look at like where is this fucking file? Where the fuck are we? Backtrace. Like, can we just fucking get the libc source code? Like, where the fuck is this? I want to go look at this motherfucker. Like, let me in. Let me in this bitch. Get adder. What is this thing? Fucking get adder slow. What the fuck? This is in line 40. Okay. Line fucking 40. This is probably just like a different version of this thing. Yeah, this is. Can we, can I get like the glibc that we have? Like, how the fuck do I do that? Oh, I mean, we have this. Can we look at like the GDB? Can I like GDB print? Like, where's this? This is on my file system somewhere. This is on my file system somewhere. Right? There's like some sort of like GDB source info mapping. GDB source list. Oh, fuck. It's like we have, okay, this is an idiot question. I'm on Nix using debug info D. In GDB, can I see, where on my file system a source file I'm looking at is? Info sources. Nice. Nice! Yeah, this guy. It's this, right? So it's like something like this. Home streamer cache debug info D client. Which is not really that helpful. Yeah, this isn't really what I want. This is not what I want. Can we do like... God damn it, stop, 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 shut the fuck up, stop, 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 stop. Doesn't Zig bundle its own libc? Not in this case. I want to see like the fucking function definition. If we just see any function that has 6 arguments, it's like GG, we understand the problem, kind of. Or if there's like an assembly function that like takes 6 arguments, something like that. Let me out, man. Kill all GDB. PS aux grep GDB. Fuck off, man. Die, 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 die. Die, die, die. Die! Fuck! Let's click this link from Grey Hatter. I'm not a bot. That does seem like it could be related. But I mean, my gut says this isn't the problem, but it could be. I think you're getting just. I mean, this would be Zig's fault, I think, not glibc, right? Because Zig's the one in charge of calling TLS getattr, right? So if that is true, then it would be Zig's fault. I don't think this is it. I think it's unrelated. Maybe, well, maybe not unrelated, not completely unrelated, but it could be something, right? However, the behavior that we're seeing seems less like that. It seems more like somebody's clobbering R9. Can we, like the thing I want here is I want like my exact libc source code. I guess, env grep libc or something. Or can we at least see like what version of glibc we have? Glibc check version. It's like likely that LDD 240. It's likely that Nix is patching us a little bit, but this is at least somewhere to start. Wait, I don't want, oh, glibc, my bad. I don't want unofficial mirror, I want real mirror. This guy. Sourceware, there's no fucking way, right? GNU here, probably. This looks like the fucking real source of this shit. We want, what was it, 240? 240. Copy. I guess download, actually, if you think about it. A unpack downloads glibc. No, not with 239. Fuck off. I want a 240. All right. We're looking for, was it a TLS get adder slow, baby? Line 40. Okay, we're close. It is like in here. Can we fucking okay, and I think that we saw it was in TLS get our tail. I think. We can check that. That's easy to check. Easy to check by hitting our breakpoint on there and just seeing if the register is fucked. You grab to the I know, but I can still get mad. I'm free to get mad at whoever I want, even if it's my fault. All right. Fuck, we're falling so much farther. We're falling so far behind on Advent of Code. But fuck it. Maybe try not hitting bugs. Yeah. That's what I tell my friend all the time. I'm like, just stop hitting bugs. And he like, you spend so much time on them. He's like, but everything's fucking broken. What am I looking for? I guess I'm trying to like update my run.gdb, and I want to look at like, it was TLS get outer tail is where we thought the problem was, if I remember correctly. Is this in the Delopen version? It is. Run.gdb. Let's see. Info. What? Hold on. Hold on. Continue. We wanted to go. Oh, fuck. Oh, yeah, we're good. Okay. Good. Next. Info registers. R9 is still good here. Oh, I guess we're in here. Okay. Step. R9 is still okay. Info registers here. R9's fucked before the tail function. Wait, okay. Interesting. Okay. Okay. R9 still chill. Oh, fuck me, dude. Fuck me. I fucking hate it when I hit continue by mistake. God damn, dude. Okay. This is where we were. Do we see R9 in here anywhere? No. Info registers. R9, chill. Okay. So I guess this seems likely, right? R9 still chill. Wonderful. Yeah. This is it, right? It's this guy. Oh, wait, no? Wait, why not? Oh, wait. I didn't hit continue, maybe. R9 chill. Next. R9 not chill. Yeah, okay. I mean, it is that. So what the fuck are we looking at here? Disassemble. So this was in DL update slot info, right? Like, what the fuck is this? You know? Who defines this motherfucker? So, somewhere in here... Like, why is he just, like, clobbering fucking everything? Like, what the fuck is happening? Array list contains for each index the generation counter, current, blah 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 blah. Um, I want to look at the disassembly again. Can we just like run it again? Run. Do I still have my breakpoint set? Yes, nice. Okay, sick. So it thinks I am at here. What? It thinks, is it 911 that it said I was at? 915. So it thinks this is index minus equals list p dot len. Okay, so sure, there's like some fucking. Yeah, I mean, 398 is here. So this is doing in a loop some shit. How confusing. Oh no, wait, this is at the end of the function. Wait, we've got a ret right here. Where's that ret going? Wait, am I stupid? Yeah. This is confusing because he thinks that I'm in TLS get attr tail, but I'm in DL update slot info as well. Right? Like that's what the disassembly is saying? It thinks I'm in DL update slot info? So something probably got inlined, yeah. Probably. Confusing. I wonder if it's like something like this. Like if this, I don't know what like GL is here. You know what I mean? Define GL. Oh, what the fuck? Oh, okay. Oh. Okay, so this, what is our backtrace saying right now? Our backtrace is saying that we're in update get attr, and then update get attr calls get attr tail at the end, right? So we're in get attr tail at 9:15 according to that, and then somehow we're about to return. I want to see like where this return goes. This ends up at, well, we're at like what should be the beginning of update get attr. Okay, that's more interesting. Oh yeah, we're right here. So it's just like, it's just the debug info is just confused. Okay. So it's something about this function thinks that he should be nuking all of our registers, right? Why does he think that? Right? It's nuking. One, two, three, four, five, six. Is this the 6 registers for a function call of these guys? DI, SI, DX, CX, R9. He says R10 instead here, which is a little concerning. Oh, okay. Where? Yeah, this is interesting. I don't know why the fuck this is happening then. He's also using R9, which is fine. He can do whatever the fuck he wants. I don't give a shit. But it's just more like... well, it is kind of interesting. Because I don't think this is supposed to be scratch registers. It is. It is scratch. I want to look for, like... I don't know what I'm looking for. Function calling sequence, maybe? R9 is color saved, but like only if you're calling a function that should use it, right? Like what I'm not 100% clear on is if... oh, I guess this is pretty clear, right? This is pretty fucking clear. Yeah, okay. So then it's like... I mean, if this is true, then it's just like Zig's insane for not backing it up. I wonder if it's like usually that they just don't happen to not, right? Like maybe most functions don't use it because it's like you need to like end up with 6 arguments called for people to like use it reliably. I want to try... okay, let's do something else. Let's pivot for a second. Let's fucking just make a C function that like takes 6 arguments and see what the fuck happens there. You know what I mean? Like, does Zig correctly back up our registers when calling C functions in general? Like, I have questions, right? Int do thing 2. Right? Can I just do like return 1 or something? And I don't know what I'm trying to do yet. Test lib .c or something. I don't know. Int do thing 2 return 1. Okay. So what I would expect to see here is what? Like, I need to somehow, like, set R9 intentionally, call this function, and read the data back from it. And we're hoping that callers of this function are backing up the register, or of any function. I guess we have do thing 3, which is going to take in int A, int B, int C, int D, int E, int F, right? Because F is going to be the 6th integer parameter. And then can we do A plus B plus C plus D plus E plus F or something, right? Like something like this? I guess this is what I'm trying to accomplish. And can I, from test exe or something, can we copy these things? I don't know what I'm trying to do yet. I'm just trying to, like, understand. I don't know. Um... Um... What is this link? Um... The compiler may have stored some... Yeah, this... Not sure. Not sure this is related. Not sure. What's the difference in the LLVM codegen? It's just like not using R9 in the same way at all. What am I trying to do here? I'm trying to compile this testlib.c as another library, I think. I think that's what I'm trying to do. So I'm trying to go like testlib.c is a dynamic library that kind of like, I don't know, man. I don't know. File is testlib.c or something. And then I think I just want to link against this thing in testlib.c or something. I'm just trying to like force these things to be separated so that there's no like inlining. And I guess this is testlib.c or something. Alright. I don't know what I'm really expecting to see here. But okay, so we do see throughout this test exe thing, we do see that the value of R9 is consistent throughout this whole thing, which I guess is good, probably. And I want to see now, maybe, can we look at like frame 4 in main? And can we just look at, okay. So he calls do thing. He does shove shit into R9 however he fucking wants. And then we call do thing again, but this Zig exported function. I wonder if it's something like exported function. Zig is initializing himself in some way. Yeah, can we look at like frame 3? So here, I see. So in Zig function entries, he is setting R9 himself. And then he is probably expecting to use it somewhere else for something. I don't know. Like, not really sure. Can we look at like maybe this? Like this log function does like hold on. We haven't really figured out what this R9 is yet, right? But we do know that it's like useful. I guess we know that because this function doesn't crash, that he's not trying to dereference it in the same way the other guys are. Okay. So what we can probably assume. Hold on. It would be interesting to know, like, what the fuck he's doing here. You know? It would be interesting. I wonder if it's like return address or something. Here he's like, yeah, what is this supposed to be? He's clearly using it for something. So he's got like, is it not the error trace? I feel like it is, right? Can we prove that? Can we prove that somehow? It does feel like the error trace, right? I don't know why, because we know that is like a hidden parameter that makes it around through a whole bunch of sig functions. And then that would also make sense because they kind of just like shove some, like they just kind of like make some stack space, right? And then they never like put anything there really. They're just kind of like at 100 back, they just like throw like a 0 in there and they're like, okay. So that seems likely, right? That like R9 is kind of like being used by all Zig functions for the return trace. Can we prove that? Can we do like a return error, like do error thing, return error, right? And then can we say like here if like do error thing catch e stood law, like error return trace here, I think. Trace is this. And can we like maybe just print the trace? Maybe just do this. I don't really know what I'm trying to see here. I'm just trying to like get a feel, I guess. I don't know what I'm trying to do. I guess I'm trying to like ob jump something. Do error thing. Oh, it's in built-in return error. So can we do run this thing under GDB and then built in return error? No, we can't do that. Fuck. But we can throw a breakpoint in do error thing before anything happens, and then figure it out from there. Hello? I guess we do need to build before we run. I guess. Something like this. Run. Okay. So I want to look at. Oh, fuck. Run. SI. Yeah, I mean, it does kind of look like this, right? It does look like this guy's just like R9, baby. Yeah, I think you're right. I think you're right that they're just kind of like hucking the error return trace around in R9. I mean, that makes sense to me. And or maybe like error, I don't know, something like that. It's got to be the trace because it's like a dereferenceable thing. It's like a pointer. Um so I guess we are trying to see if by calling I want to see what happens if we have like extern function do thing, was it 3 that takes an A, I32, B, I32, C, I32, D, I32, E, I32, F, I32? I wanted to see if Zig preserves this correctly. You know what I mean? So if we call like do thing 3 here, 1, 2, 3, 4, 5, 6, like, does he start like backing this up quickly? Hold on. Am I stupid? Uh, frame 1, disassemble. Is he calling? Okay, nice. Not okay. Yep. Let's fucking go, baby. Okay, this is so clear, right? This is so clear. So in a normal fucking function, he's like, he's like, oh shit, we used R9 for something else. We got to put that shit back, right? Especially before doing something errorable, right? We're assuming. And so I think the bug is that he's not injecting this when retrieving thread local storage. And this only manifests, this probably manifests like anywhere when using the debug backend where thread local storage is hit, right? Because he's smart enough not to fuck it up on like a normal C function call, right? And then I wonder, okay, the next thing that I want to check is if we take the 6th parameter out. Oh, this is supposed to return something, by the way. I guess it technically doesn't matter, but okay. So I want to know. We also have do thing 2, which takes nothing, right? If I remember correctly, do like test lib.c. So this is do thing 2, returns an int, takes nothing. And if I call do thing 2, does he do the same shit? You know what I mean? Yes. Yes. Okay. So this is good, right? So the zig thing is smart enough to know generally that when he calls anything that like passes a C call convention barrier, he has to reset the error trace. We're assuming it's the error trace, right? And it's probably something like the thread local storage thing just like fucks this up in that it doesn't really understand that it might be something that hits the CABI. Does it do it even when linked but not linked but with DL open? I'm not sure what you mean. If you mean that he is like so I think the only reason that this isn't a problem when we don't DL open is that it just happens that the thread local storage function takes a path that doesn't clobber R9. Qualcomm seeks this. I don't really understand what you're getting at. I don't really understand. Well, I don't understand why everybody's like why people are talking about Qualcomm C. It seems unrelated to me. Right? Because Qualcomm C is for when we are exporting a function for consumption by C, or we're trying to like as a function say that we have a calling convention that we want to match. But like this isn't the problem. The problem is that we're calling a function that we've imported without like understanding that. And by we, I mean like the Zig compiler would be my guess here. if I understand correctly. Okay. I'm going to it's getting called by C's DLSim, right? How do I say this? Sorry, I'm trying. Let me draw it. Let me draw it because I think that I am not fully explaining this. So the test case is C function or like C runtime, right? We'll say that we're like in like main.c or something, right? In here, we call a zig function, right? So either through, I guess we either go through like LD like resolved function or through DL resolved, right? Function. Okay? These guys both go back through to the same C function or the same zig function. Zig function. Right? In here, this zig function will be like R9 equals error trace. For when like something returns an error, we want to do the backtrace, blah, 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 right? Then, a bunch of shit happens, and he then calls thread local storage get adder. Right? And now the problem here is that he is not injecting he's not like flagging this as like a C API, right? He's not then saying like R9 equals error trace again here, which he is when we call like actual C APIs. He's not doing this, right? And so the problem is in this path, when we are loaded by LD, like this function internally knows that, right? And so he will do something different than in this path. And so because we are in this path, he touches R9 and it gets clobbered, and then we fuck up our error trace. You know what I mean? Now I think that Pascal Bayer is completely right. Yes, I agree. Oh, nice. You found. I missed the part where you found where it gets emitted. Yes. Yes. I 100% agree. I think this is where the bug is. And I think that all we have to do is like inject a like restore the error trace thing after this. I think, but I don't know enough about like the Zig codegen, and it would have taken me like forever to find this. So I think that what I'm going to do is I'll probably message Mlug, see if he answers me. If not, I'll file a Codeberg bug, because I'm not 100% sure that I like understand the problem correctly. But I think that we found something. I think, and I guess we have to confirm that this still happens on like Zigmaster. But this is like a really fun investigation. This is really fun, and if we can fix this, this is huge because this will like. There's multiple projects where this has fucked us. Codeberg, Codeberg, BERG, Codeberg, I think it is, which is where Zig lives now. They got off GitHub. I just searched for the symbol. There are like 3 occurrences. Nice. Okay, cool. I'm not sure. This is going to be a happy hour. This was an interesting investigation, so I might post this on the main YouTube. We'll see. But if I do, then people who are watching on the main YouTube, this is the type of thing that you might find in happy hour, which is usually stuff that doesn't get posted here because it's like harder to find a narrative for what we're doing. And if you want access to those VODs, Patreon, YouTube members, Twitch, if you pay in those places, you get access to VODs. Otherwise, it's like if you catch it live, it's free. We stream most days 12:34 Pacific time. It is 4 o'clock now if you're live. So every day, come back 3.5 hours ago to now. A good chunk of stuff gets backed up to the YouTube, if it's, again, something that's like titleable, thumbnailable, and all that. But yeah, thanks for watching. YouTube, peace out. Twitch, let's find someone to raid.